Okay students, this is the continuation of the last class. Last class we have derived the relation between small g and capital G. And one more important thing, the relation between small g capital G understood, no? As you are going away from the earth, how g is varying. So before that you should know what is the direction of acceleration due to gravity. You see here, this is earth. Here I am standing, my mass is small m. So this is attracted towards the center of the earth. So this is the radius, no? Radius direction is along this direction. Agree? But the attractive force is towards the center. That is along this direction. So the force, attractive force between earth and my mass, capital G, capital M, small m by r square. Here you should write one unit vector r cap minus. Why minus? This is radial direction, but force direction is opposite to the radial. That is why minus. You understood now? Okay, this is direction of gravitational force on my body with respect to radial direction. This is the radial direction. This is r cap direction. R cap is a unit vector. Okay. Now we will write this also. G is equal to Gm by r square. This is capital R square. This is the radius of earth. R square. This also minus, you have to write. R cap is a unit vector. Here G is a vector. Acceleration due to gravity also vector. The direction of G is always towards the center of earth. Now what we will do? How G varies as you are going away from the earth. A general formula already I have written. G equal to Gm by r square. This is at a distance of r. This is the center of the earth, and this is the mass of the earth. The distance at this point, suppose this is point A. At A I am going to calculate what is G. Then what happens? As r is increasing, G decreases. This is very easy. Okay. So if you take from here to here, h height above the earth. From here to here, capital R. What is capital R? Radius of earth. Then how the formula looks? G is equal to G capital M divided by R plus H whole square. R plus H whole square. This is G prime I am calling, because why it is G prime? This is acceleration due to gravity due to the earth at a distance of r, that is small r, that is nothing but r plus h. Agree? Now by seeing this, as h is increasing, G decreases. Okay? So if you go away from the earth, G is decreasing. This is understood. Next part, what we will do? If we go deep inside the earth, it will increase or decrease. So first, what you guess? If you are going inside the earth, R is decreasing. R is decreasing means G will increase. Okay? But it is not so. If you are going inside the earth, G decreases. If you are going away from the earth, G decreases. In the both the cases, G value decreases. How it decreases? Now we will derive. Now what we do? I am standing on the earth. Earth is attracting me. Now I will dig some depth inside the earth. Maybe some 20 meter. I will go inside. I stand again. Then still earth attracts me, no? Then what is the difference between the force when I am standing on the earth when I am standing inside well of a earth. So what I am telling, suppose I am standing here. So at this time earth is attracting me. Okay. Now I went deep inside. I dig some well here. I went inside. Now I am standing here. Okay. So here also earth is attracting me along this direction. Here also earth is attracting me along this direction. Here force is F1 I am calling. Here force is F2 I am calling. Then what can you guess? F1 is more or F2 is more? You tell. You can very well tell. F1 is more or F2 is more? So what I am telling, F1 is greater than F2. But force formula you know, no? That is F equal to mg. My mass is same, but g value is changing. G value on the surface of the earth is different from G value at a depth inside the earth. Then why it is so? From the formula, G equal to Gm by R square, already you have written, no? G is equal to Gm by R square, small r square I will write. If R decreases, G should decrease. Sorry. If R decreasing, G should increase. When G is increasing, M into G should increase. With respect to that, the F2 should be more, but it is not so. Agree? From the formula, R is decreasing, denominator decreasing, so this entire value increases, G increases, but it is not so. What is the magic in it? What is the magic in it? So when I am standing here, the force is more than when I am standing inside the earth. The reason is like this. Now I will divide earth into two parts. This portion of earth attracting you. Remaining portion, suppose here you are here, no? Remaining portion, what this is doing? This portion, this mass of this entire mass, जो earth है, this is attracting you. Suppose you take this portion of the earth, this portion of the earth. So this portion of the earth attracting along this direction. So on you there are now two forces. So complete this portion. Okay, I am writing here. You are here. So complete this portion is attracting along this direction. Suppose okay, here I will write along this direction. But this portion of the mass attracting you along this direction. That is why the net force on you decreases. Net force on you decreases. It means the effective mass of the earth is decreased. In the formula, this m also changing. M value also changing. When you are going deep inside, only this much portion of the earth only attracting you. And remaining portion, which is another side, attracting you in another direction. So net force come hoga, so G value भी कम होता है. Okay? Now it is clear, no? Now we will derive the formula for acceleration due to gravity as you are going inside the earth. Already I told, if you are going away from the earth, it is decreasing. It is a simple formula. Now if you are going inside, then what happens? Simple formula, you write G is equal to standard formula Gm by R square. Okay. So if you go inside, I am calling it as G prime is equal to G into M prime by this R value is changing, no? R value I am calling it may be some different value, R square. This is R square. R square means if you are going deep inside, no? So inside जा रहा है आप लोग इसके पहले क्या लिखना है? This M prime is different. M prime how to calculate? M prime is equal to density of earth. You assume density of earth is constant and uniform into 4 by 3 pi r cube. 4 by 3 pi r cube is volume of sphere. What is this volume? I told you already. This is the earth. I went inside, no? This portion, only this portion only attracted by you, or you are attracted by this portion. So this is R. This is the radius of earth total. So for this total portion volume is 4 by 3 pi r cube. So m prime is mass of this portion. This portion mass is m prime. So density into volume, that is the mass. So m prime is equal to rho into 4 by 3 pi r cube. R is the radius of the portion. This one. Now you can very well substitute. What you will get? G into m prime equal to what? Rho into 4 by 3 pi r cube divided by r square. A square a cube cut hota hai. Then what you will get? G prime is equal to G into rho into 4 by 3. I will write 4 by 3, no? 4 by 3 into G rho r. What is the r? Radius. Means if you are going from the center of the earth to up to surface of the earth, G is increasing. So because when you are going from center to the top surface of the earth, R is increasing, no? So if you going inside, R is decreasing. So if you are going inside the earth, R value is decreasing. That time G value decreases. So this is a beautiful formula. It is proven now. If R is decreasing, G value is decreasing. What is R? R is the radius of the earth. Means you are going inside the earth, matlab the portion of the earth, the radius, that is decreasing, no? The portion of the earth, with that it is attracted. That value is decreasing. So G value decreases if you are going inside the earth, and G value decreases if you are going away from the earth also. Okay? Some two more points you should remember. The G value is maximum at the poles, at North Pole and South Pole. Maximum on the surface of the earth. Okay? It is minimum on the surface. If you take surface of the earth, on the equator it is minimum, at the poles it is maximum. Okay? If you are going away from earth, it decreases. If you are going inside the earth, it decreases. On the surface of the earth, at the poles it is maximum. On the equator it is minimum. Okay? Thank you for watching. Please like this video, share this video and subscribe my channel. Thank you.